Let's talk about thermodynamical radiation in this lecture. Well, I'm using the word thermodynamical because have been talking about thermodynamics, but radiation actually itself is an independent concept. So we know that if we have a hot system and if we leave it in a surrounding which is at lower temperature than the system itself, the system actually loses energy and comes to the same temperature as the surrounding. And this happens because of radiation. And experimentally, it has been observed that the radiated power is equal to sigma A E T to the fourth. Now, this is true when surrounding is set at 0, so which means you put it in some 0 degree temperature, which really doesn't exist, but let's say if you put it in a space which is almost as good as 0. Okay, so what are these things? What is P? First of all, P is the power radiated, which means how much joules per second energy is radiated from the system. So every second, radiation is a continuous process. It's going to happen all the time until the object comes to the same temperature as the surrounding. So it's per second, joules per second. Sigma, well, this whole law is actually called Stefan's law. And sigma is called is actually the constant. I don't know what this is called. So sigma is a constant depending on the type of material. Well, actually, I'm wrong. It's not really depends on type of material, but sigma is a constant, which I think has a value of 5.7 multiplied by 10 power minus 8. Okay. Okay, so that's a constant, and we can guess the units from the formula itself. So it's gonna be watts, meters per meter square per degree Kelvin to the power 4. A is the surface area of the guy that is radiating energy. So if you make a bigger area, let's say if you have this big red hot iron ball and you have a larger red hot iron ball, let's say use the same 1 kg in forming this ball. This remains hollow because it has to be made from 1 kg itself, and let's say they start from the same temperature T. Then finally we will see that this guy actually will come to the will lose energy faster than this guy. So there will be more radiation in this case compared to this case. Why? Because the area in this case is larger. Okay, so you see that power radiated is proportional to the area. What is E? E is called the emissivity. Now this is something that depends on the material used. So let's say if you have iron ball which are same in size, they start from the same temperature. Let's say you make this from iron, but you make this, let's say, from ceramic. Then you will see they will have different cooling rates. They will have the radiation per second are going to be different for these two guys. Even when the surface area is the same, the starting temperature is the same. So E plays a role. Also, if so, it's directly depends on E. Also, if you have a case when the same balls are there, same material is there, which means same E and same area, the radiated power is going to depend on which is at a higher temperature. So if this is T1, this is T2, we will see that if T1 is greater than T2, then P1 will also be greater than P2. As a matter of fact, we already know from the equation that power radiated is proportional to T to the power 4. It doesn't really depend on T, but T to the power 4. So you can say P is proportional to A, P is proportional to E, and all of this you can combine to write P equals sigma A E T to the power 4. Now if you have the case when, now this is true when T, the surrounding is 0. If you have surroundings set at temperature Ts, in that case your P is going to be sigma A E T to the power 4, let's make this a subscript, minus sigma A E T S to the power 4, because this is the guy which is radiated by the object, and this is the guy, this is the heat, let me rephrase, this is the radiation radiated by the object, but at the same time the temperature outside is not 0, is going to absorb heat from the surrounding of this amount. So a better emitter is also a better absorber, which depends on E. So usually black color, as we see, is a good absorber and good emitter. That's why we have black umbrellas. So so surrounding is at some temperature, surrounding is also radiating because of the temperature, and this radiation is absorbed by the object. So this is the original radiation, but it also has a subtraction because it's going